Right now, somewhere above your head, space itself is being torn apart. You can't see it, you can't feel it, but it's happening. Light is bending, time is slowing, matter is being stretched into threads thinner than a human hair. You've probably imagined falling into a black hole before. Your brain pictures it like falling off a cliff. 1 second you're there, the next second, gone. But the real answer is far stranger than that. Because if you actually fell into a black hole, you wouldn't just disappear. You'd become the last living proof that time is not what you think it is. Start with the basics. A black hole isn't a hole at all. It's a region of space where gravity has become so extreme that nothing, not light, not matter, not information itself, can escape once it crosses a certain boundary. That boundary has a name. Scientists call it the event horizon. The event horizon isn't a physical wall. There's no surface to touch. It's simply the point of no return. Cross it, and the universe you knew is gone forever. Not because you exploded, not because you burned up. Because the geometry of space and time has folded in a way your mind was never built to comprehend. Here's where it gets strange. The physicist Karl Schwarzschild worked out the mathematics of this boundary back in 1916, just months after Einstein published general relativity. He was serving in the German army at the time, doing physics calculations from the front lines. He calculated the exact radius at which gravity becomes inescapable. That radius is now named after him. The Schwarzschild radius. For a black hole the mass of our sun, that radius is about 3 kilometers. For something the mass of Earth, it would be smaller than a marble. Terrifying, right? An entire planet, crushed into something you could hold in your palm. Now picture yourself approaching one. Not a small, black hole. A supermassive one, like the kind sitting at the center of most galaxies, including our own. As you fall feet first toward it, something unusual happens to your body. The pull of gravity on your feet becomes stronger than the pull on your head, because your feet are closer to the black hole. This difference in force has a name too. Astrophysicists call it spaghettification. You are, quite literally, being stretched like a piece of pasta. For a stellar mass black hole, this would happen fast and violently, long before you ever reached the event horizon. Your body would be torn apart within seconds. But for a supermassive black hole, the math changes completely. The gravity gradient is gentler. You could cross the event horizon whole, alive, intact, not even noticing the exact moment it happened. Doesn't that sound almost peaceful? It isn't. Because outside, something impossible is unfolding. Someone watching you fall from a safe distance would never actually see you cross that boundary. To them, you would appear to slow down, and down, and down. Frozen, forever, at the edge of the horizon, your image stretching and fading into darkness. This is where Einstein's theory of general relativity stops being an equation on a chalkboard and becomes something that reshapes your entire sense of reality. Time itself moves slower the closer you get to a massive object. Physicists call this time dilation. And near a black hole, the effect becomes extreme. To you, falling in, time would feel completely normal. Your heart would beat the same. Your thoughts would flow the same. But to the outside universe, you would seem to take an eternity to fall those final few meters. Two versions of the same moment, both true, neither one more real than the other. The physicist Roger Penrose spent decades proving something even stranger about what happens after that boundary. In 1965, he showed mathematically that once you cross the event horizon, every possible path you could take, no matter what you do, leads inward. Not because gravity is chasing you, Because inside a black hole, falling toward the center isn't a direction anymore. It's the direction time itself flows in. You read that right. Inside a black hole, the future isn't somewhere ahead of you. The future is the center. Penrose won the Nobel Prize in Physics in 2020 for this discovery, sharing it with the team that found evidence of the supermassive black hole at the center of our own galaxy. So what actually happens at the center, honestly, nobody fully knows. Our equations predict something called a singularity, a point of infinite density, where the laws of physics, as we understand them, simply break down. Stephen Hawking spent much of his career studying exactly this boundary between what we can calculate and what remains unknown. He showed that black holes aren't entirely black either. They slowly leak a faint stream of radiation, now called Hawking radiation, which means that even black holes eventually evaporate, given enough time, trillions upon trillions of years, longer than the current age of the universe, by an almost incomprehensible margin. Here's the twist that changes everything you just imagined. Some physicists, including Kip Thorne, who helped shape the black hole visuals for the film Interstellar and later won the Nobel Prize for his work detecting gravitational waves, have explored a wilder possibility. What if certain black holes don't end in a singularity at all? What if mathematically, some solutions to Einstein's equations allow for something called a wormhole, a bridge connecting one region of spacetime to another? It's speculative, unproven, possibly impossible to survive even in theory, since the same tidal forces that stretch you like pasta would likely still apply. But it means the honest scientific answer to falling into a black hole isn't simply death. It's a genuine unknown, one of the last true mysteries left in physics. Which brings you back to yourself standing here, feet on solid ground, nowhere near a black hole. Why does any of this matter to you? Because you already live inside a version of this paradox every single day. Time already moves differently for you than it does for other people, just not in ways extreme enough to notice. An hour with someone you love passes in seconds. An hour of pain and grief stretches into eternity. Einstein wasn't only describing black holes when he described relativity. He was describing something your body already knows. You have felt time slow down. You have felt it vanish. You have felt entire days blur together and single moments last forever. Somewhere above your head, space is still being torn apart. But so is the moment you're living in right now, stretching, bending, disappearing the instant you try to hold on to it. You've probably imagined falling into a black hole before. Now you know the truth. You're already falling. You have been the whole time. If any part of this changed how you see time, it's worth passing on. Someone else out there is asking the same questions you just had answered. A share puts this in front of them. A subscription means the next mystery finds you before you go looking for it. Like this video, if it reshaped even one small piece of how you think,